Hi, welcome to day 7 CKA Exam Daily Recap. As per usual, I have these slides that I create daily to kind of summarize some of the learning content that I've learned as part of the Udemy course that I'm taking from CodeCloud. Today's topic will cover Kubernetes security, specifically certificates of authentication. By no means do I expect to cover all the topics in an exhaustive manner, but more so just some high-level questions and answers as to what I've learned and acquired. So the first question I have is, what are the three main certificate types in a Kubernetes cluster, and what do they secure? Server certificates, API server, etcd, kubelet, prove component identity to clients. Client certificates such as admin users, kubescheduler, kubecontroller manager, and kubeproxy authenticate clients to the API server. And then you have CA certificates or certificate authorities, which sign and validate all other certificates in the cluster. Now, how does the certificates API automate certificate management? Well, we have admins who create certificate signing request objects, which contain base64 encoded CSRs. The controller manager with the CA cert key pair reviews and approves or denies requests. Approved certificates are signed and returned in the CSR objects status field for retrieval via kubectl. Now, what three things does a kubeconfig file contain, and why does it eliminate the need for certificate flags? So this is, to put it in different words, when you're using kubectl, you can pass in the other additional CLI arguments like server, client, certificates, and so forth. Now, to avoid that, you can use what's called a kubeconfig file, and in the kubeconfig file, you can specify clusters, which are the server URLs and CA certs, users, cluster certs or tokens, and context, cluster user pairs with optional namespace. The kubectl command reads the file automatically instead of requiring server client certificate client key flags on every command. And certainly you could also expose an environment variable like kubeconfig to pass a different path, but that's kind of a little bit more deeper in depth. Now, how do you verify certificate details in a running cluster? You inspect static pod manifests in etc Kubernetes manifest for certificate paths. Then you can use the OpenSSL utility with X509 with a set of different additional flags that you can inspect the subject, issuer, validity dates, subject alternative names, so on and so forth. You can check the API server client CA file to identify the cluster CA as well. Now that's all I had for day 7. I hope to see you in the next one. Take care. Goodbye.